Hi there. Now we continue our lecture on autocorrelation modeling problem, whereas this problem actually the third diagnostic problem for the multiple regression model. Well, let's start. As introduction, the autocorrelation is also known as the serial correlation or lag correlation that explains the relationship between observation between the same variable over different period of time. Autocorrelation is calculated as a function of mean and variance. Autocorrelation occurs when the error term in one period related to the error term in the previous period. This problem always happens in time series data. As you can see in the graph, you can see the positive and negative autocorrelation, where the positive autocorrelation, the movement of the variable, the movement of the error seems like quadratic function, whereas we can see that the negative autocorrelation is movement like it's not like random, but it seems like the movement of the data is moving together like this, right? In the specific situation, the positive autocorrelation when rho is larger than 0, or when positive error then follow positive error and negative error then follow negative error, while the negative autocorrelation can be said that the value of rho is less than 0, or when positive error tend to follow negative error and negative error tend to follow the positive error. How autocorrelation can happen? It can be many reasons. The first reason it can be happen naturally, because usually the autocorrelation problem happen when the modeling have the lag variable, or it can be happen because of bias specification, like omitted important variable or excluded irrelevant variable, or excluded the relevant variable, like, okay. Therefore, we made incorrect functional form in estimating purposes. Third, present of lag variable, like the first one, and this is the model. And the fourth reason is because of the cobweb phenomenon. Like this year, for example, this year quantity depends on the last year and the last 2 years production. That might be the cobweb phenomena. You can explore about cobweb phenomena through readings. Right. Let's continue how to detect autocorrelation problem. The autocorrelation problem can be detected through run test or Dubin-Watson test, among many other methods. However, in this lecture, only focus on Dubin-Watson or DW method only. Yeah, the Dubin-Watson or DW formula is like this. However, don't worry too much about this formula. You don't have to memorize this formula, because in this course, usually the software will calculate the value of Dubin-Watson through the multiple regression in SPSS software. Okay, let's continue. Now I want to show you how the Dubin-Watson statistic distributions, yeah, and the statistic distribution for Dubin-Watson have the value of k and the n number of observation, and you will be given, for example, the k is 2, the number of observation is 15, so the value for DL and DU it would be 0.95 and 1.554, and you have to see here the alpha value here is 0.05, meaning 5%. For Dubin-Watson, we have two types of table value for alpha, whereas the first one is 1%, and the other one is like this, the 5%. So this table only show you the example for 5%. Don't worry too much. In your econometric model, you already have for both type of alpha, 1% and 5% for your reference. This is the DW distribution. You can see that you must make sure that you know how to draw or sketch the Durbin-Watson correctly, whereas we divide the distribution into few sections. The first one, we put dl, du, 4 minus du, and 4 minus dl. Okay, can we change 4 to 3 or 4 to 2? No, the 4 is a constant. You cannot change the number 4 because 4 is the formula. So maintain 4 in every case of autocorrelation when you deal with Durbin-Watson. Okay, now the first section is positive autocorrelation, and here is fail to detect Durbin-Watson, fail to detect autocorrelation, and no autocorrelation, and here again fail to test Durbin-Watson on fail to test Durbin-Watson, yeah, and the final zone is negative autocorrelation. What is the meaning by this? Okay, let's go to the next slide. Okay, as example, let's assume that you get this data from your SPSS result and make sure you have this result in the circle. Right. When you have the result, this is actually your Durbin-Watson value given by your estimation regression result in SPSS. Let's say that your K is 4, meaning that you have alpha 0, alpha 1, alpha 2, alpha 3, and alpha 0, alpha 1, 2, and 3. So you have to minus 1, you have to minus constant, so your K prime is 3. And given in this situation, given n is 20. Right? So remember this information. And when you have this information, you have to use the table. Now n just now is 20. So n here is 20. And K prime is 3 because here is K prime is 3. So K prime here is 3. Then when you go both information here, you get dl is 0.998 and du is 1.676. Transfer your information into here, right? dl, du, 4 minus du, 4 minus dl. So here you just put the information dl equal to 0.998 because here is 0.998. And du is 1.676 because here given value for du is 1.676. Then you have to calculate for 4 minus du and 4 minus dl by given the formula. Okay, how to get this number? You have to use the statistic table. Don't worry, it's provided in your econometric model. I hope you can understand now of how to use the table. Then let's go back to the value of Durbin-Watson. When you already allocated all the information here, now you can decide where your Durbin-Watson value will be dropped. And when we see here, the Durbin-Watson represented by X in the graph is 0.845 is in the first zone. And the first zone represents the positive autocorrelation. Therefore, conclusion, for example, based on the information given, also according to the graph of Durbin-Watson distribution, it can be seen that the positive autocorrelation problem is happened in the estimated model at 5% significant level. Okay, this conclusion is only for this situation. However, you can make your own conclusion depend on the information from your data and modeling information. Now let's try another example. Now I give you this example. I want you to sketch the graph Dubin Watson and submit in my group as attendant at week 11. I give you all information here where K prime is dependent of how many your independent variable excluding constant. Okay, you be given K prime, meaning that you don't have to minus 1 anymore because this is already K prime. N equal to 20, DL is 1, DU is 1.68, 4 minus DU is 2.32, 4 minus DL is 3, DW is this value. So you have to identify, well, the conclusion given here is yes or no. You tell me whether it's correct or it's wrong. Okay? And make sure you use table at 5%. Alright, I think it's only for now. I hope you can understand the explanation of autocorrelation problem today very well. And if you have any problem regarding the explanation today, we will have further discussion on next week on our online lecture via Google Meet in week 12. So I hope you can try to do the exercise here and make sure you submit. When in the My Group, I will give you the due date before you can submit your final result. Okay, thank you so much. Goodbye and Assalamualaikum.